Welcome to another week. We're going to continue on with Chapter 12. We're going to finish Chapter 12 this week, and that means next week we're going to see our first exam. So I want to talk a little bit about what that's going to look like. So the exam is going to be in person on the 23rd. So Wednesday of next week, so that'll be in week 5. We'll meet at 11 a.m. You'll have the full 2 hours. You're going to want to bring a scientific calculator. There will be a periodic table and useful information provided with the test. On Blackboard, there's an Exam 1 folder that is now visible, or it'll become, depending on when you're watching this, let me see what, the 14th, so it's Monday. So it'll show up on the 14th. And you can go in there and find the useful information that's going to be on the test. The periodic table is going to be on the test. Useful information is like equations, some of the equations in Chapter 12 here. Chapter 11, all the concentration units, solubility rules, polyatomic ions, that kind of stuff that has been provided before as useful information when we'll be doing practice in the classroom. The test is going to cover weeks 1 through 4. So everything we've talked about so far, chapters 10, 11, and 12, so including what we're going to talk about this week. And so anything that we've covered, there's a review that's contained in the Exam 1 folder. One of the ideas of the review is to kind of help you guide what topics are the most important. You know, we've talked about a lot of things, but we only have 2 hours for the test, so I can only ask so many questions. So, you know, we'd be looking at things that are the most important. So I'm looking for what are the most important things. That's how I generate identify where to put participation questions. That's how I identify what questions to include in homeworks, what questions to include on the exam, what questions to include on the review, right? So what are the highlights? What are the important things for you to know? Get some practice by doing the review. To incentivize you to do it, I'll give you 3 bonus points on your test score. So if you just complete and turn in the review, you get 3 points added to your test grade. And when you do submit your solutions to the review, you can see the answers. So I have an answer document that will be visible once you turn in your review. And you can turn in whatever you want, whatever format, image, PDF, whatever it is. The test will be a free response entirely, so it'll just be questions that you are writing answers to. Similar format to the participation questions, similar format to the practices that we do on campus and the review that you'll see, where I ask you a question and you just write it. And you just need to provide the answer if that's all I ask. If I'm looking for more than just the answer, there will always be a bold and underlined instruction. We've seen this in the participation quiz. We've seen this in the practices we do. On the review, it's there. Explain how you know. Show your work. That's always going to be required for anything numerical. Justify your answer if you're making a choice, if you're deciding something. If those aren't required, you can just give an answer. If I don't ask for the explanation, you don't need to give one. When you do give explanations, they should be complete ideas. It doesn't need to be complete sentences or something, but a coherent and complete idea. It can't just be because or just a word, right? Like exothermic, right? Like something like that. It needs to be, it will be because it's, you know, it shifts this way because it's exothermic, or it changes this way because it's exothermic, something like that. Whenever you're doing something numerical, you need to show your work, and I always want to see units. You know, by showing your work, by providing explanations as to how you know something. One of the things it allows me to do is award partial credit. With, you know, multiple choice, you're just right, wrong, and you can potentially be right for a wrong reason, which isn't ideal. So I like giving partial credit, showing thought process. You might not necessarily know how to get to the answer, but you know the right units that the answer should have. Or conversely, if you know what the answer is, but you can't figure out the units, that's a problem, right? And so that's part of the answer as well. When it comes to additional study strategies, there's a couple other things in the exam review, in the Exam 1 folder. First off is a printout or guide with all of the learning goals. You could think of this like a study guide. It has a description of the skills you should be able to do with the material. So one of the things that helps you do is kind of guide to what level to know topics. So, you know, when it comes to, for example, you know, the concentration units from Chapter 11, it's like, do you know how to calculate concentrations, you know, to convert between concentrations? Not necessarily. I talked a little bit about when we use different concentrations. That's not really something I'm going to ask you about. I'm going to expect you to calculate concentrations, convert between concentrations. That's the skill you want to be able to do. So I would look to that learning goals document and see what level do you need to know things to. You can also make your own. You kind of think of it as like a study guide. You can make your own study guide and compare what sort of topics are you kind of not including on your study guide, because either you don't know about them or you're hoping they're not going to show up on the test. Those are probably the things you should study. There's also a page in there of vocabulary terms. I just went through and wrote out terms for each chapter that are important for you to know. I'd encourage you to, a good use of this would be to like make flashcards, either manually or having like a chatbot make flashcards for you. And then you're working through learning that terminology. I started doing this a little bit ago, a couple semesters ago, where I found that students didn't understand questions. And I think they were missing out on some of the vocabulary. So instead of just focusing on solving problems, giving you a tool or kind of a guide, these list of vocabulary terms to learn. And then you can make flashcards, which ensures that you understand the language that's in questions on the test, and helps build some recall skills, which are useful then. And you've worked to establish some memory pathways of what molality is, or what integrated rate laws are, or primary intermolecular forces, those sorts of things. Outside of that, I would take a look at problems in the lecture slides, both examples and participation. I write those and I write the test. Same thing with participation quizzes. Same thing with the practices that we do. I write all of those myself, and then I write the test. So they're going to be similar topics, similar coverage, similar focus, similar framing of the material. Week 4 homework also covers material on the test. I encourage you to take a look at that. Earn points while you prepare. It's part of your grade. It's also material on the test. So working through that homework is going to be valuable, getting more practice, more time spent learning this material. Kinetics in this case. Okay. That's it for the exam. We still got to do week 4. We still got to do this set of videos. If you have any questions about anything, let me know. Otherwise, I'll see you in the videos. Continuing on with chapter 12, learning more about kinetics.